So I have m sequences, each of length k, which are my database of short strings, and I have my long query sequence of length n, and I want to find every instance of every word in this database as it appears as a substring of my query. What I could do is pre-process my database by building an Aho-Corasick Automaton. So over here, I'm showing the Aho-Corasick Automaton corresponding to this database of short strings. It might look a little daunting at first, but let's break it down. So first, completely ignore the purple stuff. Only look at the blue solid lines. The blue solid lines are exactly the multi-way trie constructed from these sequences. ACC, I go ACC. ATC, I go ATC. CAT, I go CAT. GCG, I go GCG. So the first step is construct a multi-way trie, exactly like a normal, regular multi-way trie from my database. Now let's tackle this purple, potentially confusing part. So these purple dashed lines, these are what are called failure links. So every single node in my multi-way trie, we should really think of as some string that is the concatenation of all of the edge labels from the root to that string. So for example, this node here, I should think of it as, oh, this represents AC. So these failure links basically, for every single node, connect a link from that node to the node representing the longest, so to any node that is a prefix, technically, representing the longest suffix that exists of that node. So in other words, here I have AC is my string. So the suffix is C. So if C exists in this, so there's two suffixes. There's three. There's AC and then itself. There's C and itself. And then there's the empty string. Those are the three suffixes of the string AC. So I would connect an edge, a failure link, from this node to the longest suffix that exists in my multi-way trie. So my suffixes, again, are AC, but excluding itself. So I can't have a link to itself. The only node that's allowed to have a link to itself is the root. I'll explain that later. So if I can't have a link to itself, that means I ignore the AC suffix. So the only suffixes I'm looking at are C and the empty string. The longest of these is C, and that actually does exist as a path in my multi-way trie. So I build a failure link from this node to C. Let's take a look at this node. So this node is the path GCG. So the suffixes are GCG, CG, G, and the empty string. Remember, I don't want to make a link from it to itself, so I ignore the full string GCG. So the suffixes that remain are CG, G, and the empty string. Out of these, which one is the longest one that exists in my multi-way trie? Well, CG, I could go C, there's no G. So CG does not exist in my multi-way trie. The next suffix is G. G does exist in my multi-way trie. So I build a failure link from this node to G. Okay, let's try a couple more. So what's a good one? So what about this node? This node is the path CAT. So the suffixes, excluding itself, are AT, T, and the empty string. The longest of these is AT. Does that exist? AT. Yes, it does. So I build a failure link from this node to that longest suffix. Let's try one more. What about this node? Actually, no, let's do this node. So this node is AT. So the suffixes of this node, excluding itself, are T and the empty string. So out of those two suffixes, which one is the longest one that exists in my multi-way trie? Well, if I start at the root, T does not exist. So this suffix, just the letter T, does not exist in my multi-way trie. The empty string, that's the last remaining suffix of AT, because I'm ignoring AT itself, so T does not exist. Empty string, yes, empty string exists, it's just the root. The root is the empty string. So I connect a failure link from this node to the root, which represents the empty string. Hopefully that makes sense. So for every single node in your multi-way trie, you construct a failure link. And again, you construct that failure link as an outgoing link from that node to the node representing the longest suffix of the node as it exists in the multi-way trie. So take your whole string, find all the suffixes excluding itself, and then the longest of those that also exists in your multi-way trie, build a link to that. Okay, so that was kind of complicated. How does this actually help us? Well, it turns out that now I can just do a linear scan of my query string to find all instances of this database. So here's my query string. I start at the root, just like a multi-way trie, and I start at the first letter. So the first letter is G, so I traverse to G. So actually, let me draw a yellow arrow. Actually, yeah, let me draw a yellow arrow. So G, I traverse here. Actually, that's going to get messy. I'm just going to use my pointer. So G, I traverse down here. Now I'm at this node. Okay, now C, I traverse down. Now I'm at this node. A, there is no A child. So let me follow my failure link and then try again. Oh, there is an A child. There we go. So now I'm at this node, and A is done. Now T. Hey, that's a word node. CAT exists in my multi-way trie, or I guess in my Aho-Corasick Automaton, but CAT is in my database. So T is done, and CAT was found. Now C is the next letter. Oh, my current node does not have a child labeled at C. Let me try my failure node. So I traverse my failure link. Now I'm here. Try C again. Oh, yep, there we go. Hey, this word exists too. This word is ATC. ATC also exists. Now my last letter in my query, G. My current node doesn't have a child labeled G. Let me traverse my failure link. My child doesn't have my current node doesn't have a child labeled with G. Let me traverse my failure link. Now I'm here. My child does have this node does have a child labeled with G, so I traverse it. Now I'm here. That's done. Now my search is done because I've used all the letters of G. So now I am here. So how long did this algorithm take? Basically, I did a constant time operation for each of the letters of this query. So if my query is length n, this is actually big O of n overall. So once I've built my automaton, not including time to build automaton. So given the automaton, assuming I've already built it, I can do a linear scan of my query to find all instances of every single word that exists in my automaton, in my database.